Here is something that the personal computer industry would prefer you did not think too hard about. That laptop sitting in the corner of your room, the one that takes 3 minutes to boot, that freezes when you open a browser, that sounds like it is working harder than it should just to display a spreadsheet, is probably not broken. It is probably not worn out. The processor has not degraded. The memory has not forgotten how to function. It is running the wrong operating system. That is a statement that sounds simple and implies something enormous. Because if it is true, if the problem is software rather than hardware, then the solution is not a new laptop. It is a different decision about what runs on the one you already have. And here is what makes this particular experiment worth paying attention to. This was not conducted on a machine that was obviously underpowered. It was not a netbook from a decade ago with a single core processor and 2 gigabytes of RAM. It was a machine that, by any reasonable measure, should still be capable of handling the computing tasks that the majority of people perform every single day. What happened when the operating system was replaced was not what anyone fully expected going in. The numbers were surprising. Some of them were almost uncomfortable to look at because of what they implied about how much performance had been quietly taken away. Not by time, not by hardware failure, but by the accumulating weight of software that had outgrown the machine it was running on. And the 30 days of daily use that followed the installation revealed a picture that was more complicated, more honest, and ultimately more useful than any benchmark result alone could provide. Here's what actually happened. Before understanding what changed, you need to understand what was happening to make the laptop feel the way it did. Windows 11 is a modern operating system designed around a modern hardware assumption. That assumption is not hidden. Microsoft published the minimum requirements clearly and publicly. A compatible processor from the 8th generation or later. 4 gigabytes of RAM is a minimum, though the practical experience below 8 gigabytes is significantly degraded in real-world use. A 64 gigabyte storage drive. A trusted platform module version 2.0, DirectX 12 compatible graphics. These are minimum numbers. Minimum means the operating system runs. It does not mean the operating system runs well. The laptop in this experiment has a 6th generation Intel Core i5 processor, 8 gigabytes of DDR4 RAM, a 256 gigabyte SATA solid-state drive. It was a capable machine when it was manufactured in 2016. It handled Windows 10 adequately for years. The move to Windows 11, which this machine technically supported through a TPM 2.0 module present on its motherboard, changed something that was difficult to quantify at first, but impossible to ignore in practice. Here is what Windows 11 is doing right now on a machine like that, before you open a single application. The operating system maintains background services for cloud synchronization, telemetry collection, Windows Update activity checking, Microsoft Defender's real-time monitoring, the Copilot infrastructure that became embedded in Windows 11 through the 23H2 and 24H2 updates, Windows search indexing, the widget service fetching news and information content, and the shell processes that run the taskbar, the notification system, and the start menu. Together, on this hardware, these processes consumed between 3.6 and 4.1 gigabytes of RAM at idle, measured after a fresh boot, before any application was opened, after background services had settled. On an 8 gigabyte machine that leaves between 3.5 and 4 gigabytes for everything the user actually wants to do. Open a browser with 6 tabs. The available memory approaches its ceiling. Open a browser, a document editor, and a PDF simultaneously. The system begins using the page files, writing memory contents to the storage drive because RAM is full, and performance degrades in the way that anyone who has experienced it will recognize immediately. The drive activity indicator stays lit. The cursor hesitates. Everything slows. Simple actions take seconds instead of milliseconds. The machine feels broken, even though nothing is broken. The processor compounds the problem. The 6th generation Core i5 is a capable chip by the standards of its era, with 2 physical cores, 4 threads, and adequate single-thread performance for the majority of productivity workloads. But Windows 11's background processes do not pause to accommodate limited CPU headroom. Telemetry services, Defender's behavioral monitoring, and the search indexing service compete with foreground applications for processor time in ways that produce the stuttering, the hesitation, the gap between action and response that users experience as the laptop feeling slow. There's also a thermal dimension to this dynamic. On a machine whose cooling system was designed for the workload profile of its era, the continuous low-level CPU activity of modern Windows background processes maintains the processor at a temperature that triggers thermal management more frequently than it would under a lighter load. This thermal activity, in turn, affects clock speed consistency. The processor throttles slightly to manage heat, and that throttling is felt as inconsistent responsiveness that further contributes to the perception of a machine that is struggling. The instinct when a laptop feels like this is to assume it is old, to assume it has reached the natural end of its useful life, to start looking at replacement options and justifying the expense by telling yourself that technology simply moves on. The hardware industry benefits enormously from this assumption. Device manufacturers need people to buy new laptops. Operating system vendors, who tie their software to new hardware requirements, create the market conditions that make those purchases feel necessary. The reality is more nuanced than the assumption allows. And the experiment that follows exists specifically to test whether that assumption holds under measurement. Linux Mint was not chosen arbitrarily from among the hundreds of available Linux distributions. Among the options that exist for users looking to revive older hardware with a capable, stable, and accessible Linux environment, Mint occupies a specific and carefully earned position. It is the distribution most consistently recommended to users coming from Windows by technical communities that have watched newcomers succeed and struggle with different starting points over many years. The reasoning behind that recommendation is grounded in design decisions that the Mint development team has made explicitly. Linux Mint's Cinnamon desktop environment, the default and most widely used of the three interfaces Mint offers alongside Mate and XFCE, is visually familiar to Windows users in ways that reduce the cognitive friction of the transition to a minimum. The taskbar is at the bottom of the screen. There is a Start menu equivalent in the lower left corner, organized into categories in a way that Windows users navigate intuitively. The file manager presents a familiar two-panel layout with a sidebar for common locations. The system settings are organized in a control panel that resembles Windows' own settings organization, enough that finding specific configuration options does not require reading documentation first. This familiarity is not accidental, and it is not superficial. The Linux Mint development team has explicitly prioritized the Windows to Linux transition experience as a core design goal of the project since its founding. The result is a distribution that does not require users to learn an entirely new interaction paradigm before they can accomplish the basic computing tasks they came to the machine to do. The installation process began with downloading the Linux Mint 21.3 ISO from the official Mint website, the version based on Ubuntu 22.04 LTS, which provides 5 years of long-term support, a stable software foundation, and broad hardware compatibility derived from Ubuntu's extensive driver testing. The ISO file, approximately 2 gigabytes in size, was written to a USB drive using Ventoy, a tool that allows the ISO to coexist with other disk images on the same drive without reformatting between uses. The laptop was booted from the USB drive by pressing the appropriate function key during startup to access the boot device selection menu. The live environment that appeared deserves attention because it is one of Linux Mint's most strategically important features for users considering the switch. Rather than requiring installation before the operating system can be experienced, the live environment runs a complete functional Linux Mint desktop directly from the USB drive, with real applications, real internet connectivity, and the complete interface without touching the laptop's internal storage. The existing Windows installation remained completely untouched. The laptop ran Linux Mint from the USB drive for 2 hours before a decision about installation was made. Firefox browsed the web, LibreOffice opened documents, the settings panel was explored. Wi-Fi connected automatically. The function keys for brightness and volume worked. The touchpad's 2-finger scrolling and 2-finger tap for right-click worked correctly. The system felt responsive in a way that was immediately perceptible and immediately interesting. Driver support was the primary technical anxiety going into this experiment. On Linux, hardware compatibility is a variable rather than a constant, and it has been a persistent criticism of the platform across many years and many hardware configurations. On this machine, with its Intel Wi-Fi adapter, Intel HD Graphics 520 integrated graphics, Realtek audio controller, and Intel Bluetooth chip, every piece of hardware was detected and functional within the live environment without any manual driver installation or configuration. This reflects the strong Linux kernel driver coverage for Intel hardware, which has been a consistent advantage of Intel-based machines for Linux adoption. The installation from the live environment took 11 minutes from clicking the Install Linux Mint icon on the desktop to the completed installation prompt requesting a restart. The installer presented clear options for partitioning, including the option to install alongside Windows in a dual boot configuration rather than replacing it, handled the partition setup automatically based on the selected option, and completed the process without requiring any command line interaction at any point. The first boot from the internal drive produced a working desktop in less than 20 seconds from the login screen. The first impression of the installed system was immediate and difficult to articulate with precision in the moment. The machine felt different in a way that preceded any benchmark measurement, any comparative analysis, any conscious evaluation of specific performance dimensions. It felt lighter, more immediate, like the gap between intention and response had been compressed to something that matched expectation rather than perpetually falling slightly short of it. Numbers first, then the explanation of what they mean and why they matter. Boot time, measured from power button press to a fully interactive desktop with background services settled and no further drive activity, was recorded across 5 measurements on each operating system following a standardized testing procedure. Windows 11 averaged 52 seconds. Linux Mint with Cinnamon averaged 19 seconds. The 33-second difference is not a marginal improvement. It is a transformation of the startup experience from something that requires patience to something that barely requires waiting. Idle RAM consumption, measured after boot with no applications open and after background services had fully initialized and stabilized, was 3.8 gigabytes on Windows 11 and 1.1 gigabytes on Linux Mint. This single measurement explains more about the subsequent performance differences than any other data point. On an 8 gigabyte machine, Windows 11 leaves 4.2 gigabytes for user applications under ideal idle conditions. Linux Mint leaves 6.9 gigabytes. That difference is not a percentage improvement to be expressed as a modest gain. It is an additional 2.7 gigabytes of working memory that the user's applications can occupy without the system reaching for the page file. Idle CPU utilization was observed across 15-minute measurement windows on each system. Windows 11 showed consistent background CPU activity ranging from 8 to 15%, attributable to Defender's real-time protection processes, the telemetry service, Windows Update background checking, and the search indexing service maintaining its database. Linux Mint showed background CPU utilization between 1 and 4%, with occasional brief spikes during the system's background update checking process. Application launch times were measured for a set of applications, representative of typical productivity use. Firefox launched from a cold start in 3.1 seconds on Windows 11 and 1.8 seconds on Linux Mint. LibreOffice Writer launched in 4.3 seconds on Windows and 2.5 seconds on Mint. The Nemo file manager on Linux Mint opened in 0.9 seconds, compared to 2.8 seconds for Windows Explorer. These differences compound in daily use. Each interaction costs less time, and the cumulative effect of dozens of application interactions throughout a working day produces a meaningfully different experience of using the machine. Browser performance was evaluated using the Speedometer 2.1 benchmark in Firefox 121 running on both operating systems. Windows 11 produced an average score of 46 across 3 benchmark runs. Linux Mint produced an average score of 53. The improvement reflects reduced competition for CPU resources during the benchmark's JavaScript execution workload, rather than any difference in Firefox's own capability. The same browser producing better results because the environment it is running in is making fewer competing demands on the processor. Battery life on a standardized rundown test, screen brightness at 50%, Wi-Fi connected and active, Firefox running with 5 tabs, a LibreOffice document open, light work being performed continuously. Produced 5 hours, 38 minutes on Windows 11 and 6 hours, 52 minutes on Linux Mint. The 74-minute improvement is attributable almost entirely to the dramatically lower idle CPU utilization on Linux Mint, reducing average power consumption during the periods of light activity that characterize the majority of a typical productivity session. Thermal behavior during a sustained 15-minute CPU encoding workload showed the machine reaching a peak temperature of 88 degrees Celsius on Windows 11 and 81 degrees on Linux Mint. The lower peak temperature reflects the reduced baseline CPU activity during the workload's initialization phase. Linux Mint begins the encoding task from a lower baseline temperature because its idle CPU utilization is lower, giving the thermal system more headroom before reaching the temperatures that trigger aggressive throttling. The explanation for all of these improvements is the same across every measurement. Linux Mint is not faster because it has better code or more efficient algorithms for the tasks these benchmarks measure. It is faster because it is not doing the things that Windows 11 is doing: the continuous cloud synchronization, the behavioral telemetry, the AI service infrastructure, the advertising ecosystem processes, the shell features that require persistent service processes to maintain their availability. Every cycle and every megabyte that Windows 11 directs toward these functions is unavailable for the applications the user is actually trying to run. Linux Mint directs essentially all of the machine's resources toward what the user is doing. Performance benchmarks establish what is possible. 30 days of actual use reveals what is practical, and the two pictures are related but not identical. The web browsing experience improved immediately and remained consistently better across the entire 30-day period. Firefox on Linux Mint, with the additional RAM headroom that the lower system overhead provided, handled 12 to 15 open tabs without the hesitation that had become accepted as normal on Windows. Pages loaded without the occasional pauses that had seemed like a browser problem, or perhaps a network problem, or perhaps just age, but were actually a memory pressure problem, manifesting as browser sluggishness. LibreOffice proved adequate for the document work that occupied a significant portion of the 30 days. Writer handled long documents without issues. Calculate processed spreadsheets with standard formulas and reasonable data volumes without complaint. The compatibility story for opening and saving in Microsoft Office formats was functional for documents of standard complexity, which covers the overwhelming majority of documents that most users actually work with. Heavily formatted documents with complex embedded objects or advanced formatting features occasionally exhibited minor rendering differences compared to how they appeared in Microsoft Word. For workflows involving frequent document exchange in professional environments where formatting precision is a requirement, this represents real friction that should not be minimized. The absence of certain applications was felt at specific moments during the 30 days. There is no native Linux version of Adobe's creative applications. There is no native Linux version of Microsoft Office. There is no native Linux version of several category-specific professional tools. The open-source alternatives, GIMP, Inkscape, Kdenlive, are capable and in active development, but they are different applications with different workflows, and the transition cost for users who have built years of muscle memory around proprietary application interfaces is genuinely significant and should be acknowledged honestly. Software discovery represented a consistent low-level friction across the 30 days. Knowing what Linux equivalent to reach for in a given situation, what to install when you need a specific capability that a familiar Windows application provides, required research that became faster as the month progressed, but never became completely frictionless. The Linux Mint software manager is well organized and comprehensive, but navigating an unfamiliar application catalog is a different experience from reaching for an application you have used for years. Updates across the 30 days required a total restart count of 2, both for kernel updates that genuinely require a restart to take effect. No update session consumed significant working time. No update imposed a mandatory restart during working hours. No update introduced an interface change that required relearning a workflow. The update experience was, without qualification, less disruptive than the Windows Update experience on the same machine over a comparable period. System stability across 30 days produced 0 crashes, 0 kernel panics, and 0 application-induced system instability events. The machine ran continuously and reliably in ways that did not require any troubleshooting, any driver reinstallation, or any system restore operations. The performance results from this experiment are real and reproducible on hardware with similar specifications. Whether those results are relevant to any specific individual depends on questions that benchmark numbers cannot answer. Students whose computing centers on web research, document writing, presentations, and video calls will find Linux Mint fully capable of their entire workflow. The performance improvement on older hardware is genuine and significant. The operating system is free. It receives regular updates with a 5-year support commitment on the LTS releases. It does not impose the hardware overhead or background service burden that progressively degrades the experience on constrained machines. The primary caveat is institutional software requirements that may mandate Windows-specific applications for exams or course-specific tools. Office users in Microsoft 365 environments will find the web-based Office applications functional through Firefox. Word Online, Excel Online, and PowerPoint Online provide adequate compatibility for standard document collaboration. The gap between browser-based Office and native Office is real at the feature edges, and workflows that depend on specific advanced functionality should be tested before committing to the transition. Developers are among the users for whom the switch most clearly and most fully makes sense. The Linux development environment, the terminal, the package manager, the native availability of the full GNU toolchain, the close relationship between the desktop environment and the server environment where applications are ultimately deployed, provides genuine professional advantages that extend beyond performance improvement into workflow quality. Casual users, whose computing consists of browsing, streaming, email, light productivity, and communication tools, have both the lowest transition barrier and the most to gain from the performance improvement on older hardware. Their applications are primarily web-based. Their workflows are general rather than tool-specific. Their hardware is exactly the category that benefits most dramatically from the shift. Gamers, Adobe Creative Suite users, and users whose professional workflows depend on Windows-specific applications face genuine trade-offs that the performance improvements do not compensate for. For these users, the honest answer is that staying on Windows or investing in hardware that handles Windows 11 more comfortably is the more practical path. Is your slow laptop actually outdated, or is it running the wrong operating system? On this machine, a laptop built in 2016 with a capable processor, 8 gigabytes of RAM, and a solid-state drive, the answer was unambiguous. The hardware was not the limitation. The software running on the hardware was the limitation, and the removal of that software and its replacement with something lighter and more precisely matched to what the machine can actually provide produced a transformation that no hardware upgrade would have delivered more effectively or more affordably. Linux Mint did not upgrade the processor. It did not add memory or accelerate the storage subsystem. It did not perform any physical modification of a machine that the technology industry's replacement cycle had implicitly classified as approaching the end of its useful life. What it did was stop asking that hardware to maintain AI service infrastructure, continuous cloud synchronization, real-time behavioral telemetry, background search indexing, advertising ecosystem processes, and a shell environment with persistent service processes, and to redirect every cycle, every megabyte of RAM, and every milliwatt of battery capacity toward what the person at the keyboard was actually trying to accomplish. The result was a machine that had felt slow for 2 years, feeling genuinely capable again within the first hour of use. That matters beyond the personal convenience of a faster laptop. In a world where the average laptop costs between $500 and $1,000, where electronic waste represents a growing environmental burden, and where the gap between what older hardware can do and what modern operating systems demand of it is widening with each successive release, the ability to extend a machine's useful life through a software decision rather than a hardware purchase represents a choice that has consequences beyond the individual making it. Not for everyone. The software trade-offs are real, and they are not trivial for users whose workflows depend on applications that Linux does not support. The learning investment is real. The situations where Windows remains the more practical answer are numerous and legitimate. But for the user whose hardware is capable, whose software needs are met by what Linux Mint provides, and whose current experience of their laptop is one of frustration with a machine that feels slower than it should, the conclusion of this 30-day experiment is difficult to argue with. The laptop was not old. Windows made it feel old. And the question that the personal computer industry has the least interest in answering, but that the evidence of this experiment makes difficult to ignore, is this. At what point does asking users to continuously upgrade hardware to meet the growing resource requirements of software that is becoming heavier rather than better stop being progress and start being something else entirely? Because the machine sitting in front of you right now, the one you have been thinking about replacing, may not be the problem. The assumption that it needs to be replaced might be.